You're standing at the edge of the world, literally. Behind you, the frozen steppe of Siberia stretches back for 1,000 miles. Ahead of you, there's a land nobody in your family has ever seen. No footprints, no trails, no fire pits from people who came before, because nobody has come before. You are looking at a continent that has never once felt a human hand. It's roughly 20,000 years ago. The world is in the grip of an ice age so severe that entire oceans have gone missing, locked up as ice sheets 2 miles thick sitting on top of what used to be Canada. And because of that, right now, at this exact moment, you're not standing on a beach. You're standing in the middle of a landmass the size of a small continent, one that doesn't exist anymore, one that used to connect Asia and North America like a bridge nobody built. You take a few more steps east, and somewhere in the next few thousand years, someone in your bloodline is going to become one of the first human beings to ever set foot in a hemisphere that has been waiting, completely empty of people, for the entire existence of our species. Here's the thing about this story. For most of the 20th century, scientists thought they had it figured out. Clean timeline, clean route, clean answer. And then the evidence started showing up in the wrong places, at the wrong dates, made by the wrong tools. And an entire academic field had to quietly admit that the textbook version was, in places, just wrong. This is a story of how humans reached North America. Let's start with the land itself, because the land is the whole reason the story is even possible. During the last ice age, so much of the planet's water was frozen into glaciers that global sea levels dropped by more than 300 feet. And when the sea drops that far, it exposes the seafloor. Between Siberia and Alaska today, there's a strip of ocean called the Bering Strait, about 55 miles wide, shallow water, not particularly deep at all, dropped the sea level by 300 feet, and that strip of ocean disappears entirely. In its place, a landmass emerges that geologists now call Beringia, and it wasn't a narrow, wind-battered bridge like the name land bridge makes you picture. At its widest, Beringia stretched nearly 1,000 miles from north to south. It was a landmass roughly the size of Alaska and Texas combined, sitting right where an ocean is supposed to be. And it wasn't a frozen wasteland either. Pollen records pulled from ancient lake sediments show that parts of Beringia were a surprisingly productive grassland, sometimes called the Mammoth Steppe, dotted with dwarf shrubs, grasses, and herds of woolly mammoth, steppe bison, horses, and saiga antelope. For the people living there, it wasn't a barrier. It was simply home. And here's where the story gets genuinely strange, because for a long time, the assumption was that people crossed Beringia quickly, like tourists passing through an airport. Get to Asia's side, walk across, arrive in America. Simple. But genetic evidence tells a completely different story. When researchers compare the DNA of indigenous peoples across the Americas with populations in Siberia, they find a population that appears to have split off from other Asian groups sometime between 25,000 and 20,000 years ago, and then just stopped. Genetically isolated, not mixing with populations to the west, not yet showing up in the archaeological record to the east. This is called the Beringian Standstill Hypothesis, and it suggests that a population of a few thousand people may have lived on Beringia itself for as long as 10,000 years before ever continuing on into North America. 10,000 years. That's longer than the entire span of recorded human history, spent on a landmass that no longer exists, that we only know about because the ocean swallowed it back up. Let that sit for a second. An entire distinct population, an entire chapter of human history, played out on ground that isn't even there anymore for archaeologists to dig into. Most of the physical evidence of the Beringian standstill is sitting under 150 feet of the Bering Sea right now. For most of the 20th century, the accepted model went like this. Around 13,500 years ago, as the Ice Age began to loosen its grip, a gap opened up between two enormous ice sheets covering Canada, the Laurentide and the Cordilleran. This gap is called the ice-free corridor, and the theory said that Beringian populations funneled south through this corridor, emerged into the North American plains, and rapidly spread across two entire continents. The evidence for this came from a distinctive stone tool technology called Clovis points, elegant, fluted spearheads first discovered near Clovis, New Mexico, in the 1930s. Clovis points showed up across North America in tight clusters dated to around 13,000 years ago, and for decades, this became known as the Clovis first model. Simple, tidy, textbook. There was just one problem. The evidence that would eventually break this model open was already sitting in the ground, waiting to be found in the wrong place at the wrong time. In the 1970s, an archaeologist named Tom Dillahay began excavating a site in southern Chile called Monte Verde. And what he found didn't just complicate the Clovis first model. It seemed to shatter completely. Preserved in a peat bog, sealed away from oxygen and decay for thousands of years, Dillahay's team found wooden structures, hide remnants, medicinal plants, and even a child's footprint. And when the dating came back, it placed human occupation at Monte Verde at roughly 14,500 years ago. Here's why that number is so devastating to the old model. Monte Verde is in Chile. That's thousands of miles south of the ice-free corridor, on the opposite end of two entire continents. If people were already living there 1,000 years before Clovis technology even existed in North America, then either humans crossed an entire hemisphere at an almost impossible speed, or the ice-free corridor wasn't the first way in at all. For nearly 2 decades, mainstream archaeology fought Dillahay's dates hard. An entire delegation of skeptical scientists visited the site in person in 1997 specifically to try to disprove it, and instead left convinced Monte Verde was real, which meant the story everyone had been taught was, at minimum, incomplete. So if people were in southern Chile before the ice-free corridor even existed, how did they get there? This is where the theory shifts from land to water, and it's called the Kelp Highway Hypothesis. The idea, championed by archaeologists like John Erlandson, proposes that as the ice sheets retreated, a narrow, biologically rich strip of coastline opened up along the Pacific edge of North America, long before the interior ice-free corridor did. This coastline was fringed with kelp forests, teeming with fish, shellfish, seals, and seabirds, essentially an unbroken food source stretching from Japan all the way down to Chile. Under this model, the earliest Americans weren't trudging through an interior corridor between ice sheets at all. They were following the coast, likely using simple boats, moving south along a food-rich highway that never required them to leave sight of the water. This isn't as far-fetched as it once sounded. Human populations had already been using boats to cross open water for tens of thousands of years by this point. The first people to reach Australia had to cross open ocean at least 65,000 years ago to do it. So the idea that Ice Age people along the Pacific Rim could island hop and coast hop their way south isn't a stretch. It's consistent with what humans had already proven they could do elsewhere on the planet. The frustrating part for archaeologists is that most of the physical evidence for this coastal migration is now sitting underwater. Sea levels rose after the Ice Age ended, drowning the very coastline these people would have walked and paddled along. We're looking for a road that the ocean swallowed twice. Meanwhile, up in the Yukon, a site called Bluefish Caves has been quietly pushing the timeline even further back. Bones found there, showing cut marks consistent with human butchering, have been dated to around 24,000 years ago. If that dating holds, it places humans in North America during the peak of the last ice age itself, right around the time the Beringian Standstill population would have still been isolated on the land bridge. This is a contested date. Not every archaeologist accepts it, but it fits neatly into the genetic story. If people had already reached the edges of North America by 24,000 years ago, then the population wasn't waiting for an ice-free corridor to open at all. Small groups may have been slipping south along the coast far earlier than anyone assumed, quietly, in numbers too small to leave an obvious trace. And then, in 2021, something happened that genuinely rewrote the opening chapter of American history. At White Sands National Park in New Mexico, researchers discovered a trackway of fossilized human footprints preserved in ancient lakebed sediment. Dozens of footprints, made by teenagers and children walking alongside adults, some appearing to be playing, one set showing a person carrying a small child on one hip, occasionally setting them down. Using radiocarbon dating on seed layers embedded directly above and below the footprint layers, researchers calculated an age of between 21,000 and 23,000 years ago. Read that again. 23,000 years ago. That's during the height of the last ice age, thousands of years before the ice-free corridor existed at all, thousands of years before Clovis technology, and right in the window when the Beringian Standstill population was theoretically still stuck on the land bridge. These footprints don't come with stone tools. They don't come with a hunting camp or a fire pit. They're just footprints, ordinary people walking across a lakeshore, utterly unaware that tens of thousands of years later, their footsteps will become one of the most important pieces of evidence in the entire debate over when humans reach the Americas. Some researchers still push back on the dating method used. Science doesn't resolve controversial claims through a single paper, but subsequent studies using different dating techniques on the same sediment have landed in the same range, and the confidence in the older date has only grown. Archaeology tells you where people were. Genetics tells you who they were related to, and that's where the picture gets even richer. In 2014, researchers sequenced the genome of a child buried in Montana roughly 12,600 years ago, buried alongside Clovis-style tools. Known as Anzac 1, this child's DNA showed a direct genetic link to the vast majority of indigenous peoples across both North and South America today, confirming a shared ancestral population. But other ancient genomes complicate the simple single migration story. Remains found at sites like Upward Sun River in Alaska revealed a previously unknown, deeply ancient population researchers now call the ancient Beringians, a group that appears to have split off from other Native American ancestors even before that population moved south, essentially a genetic fossil of the standstill population itself, discovered thousands of years and thousands of miles from where their story began. Put together, the genetic evidence increasingly supports not one clean migration, but a series of population splits, isolations, and movement stretched out over more than 10,000 years, layered on top of each other like sediment. So which theory is right? The ice-free corridor, the Kelp Highway, the early coastal arrivals at Bluefish Caves and White Sands? Increasingly, the honest scientific answer is probably all of them at different times. The current working model looks something like this. A population becomes isolated on Beringia for thousands of years. Small coastal groups begin moving south along the Pacific Rim, potentially as early as 20,000 or more years ago, using boats and following the Kelp Highway south, reaching places like Monte Verde in Chile long before the ice-free corridor even exists. Later, once the interior corridor opens around 13,500 years ago, an additional wave of people moves south through it, developing and spreading the Clovis tool tradition across the interior of North America. Rather than one triumphant crossing, it looks like the peopling of the Americas was a long, uneven, repeated process, unfolding across thousands of years, involving different routes, different technologies, and populations that in some cases didn't even know the others existed. There's something worth sitting with here. For most of the 20th century, we told this story as a single, clean event, one crossing, one people, one moment when humans stepped onto an empty continent for the first time. The real story is slower, messier, and in some ways more human. Small groups, waiting out an ice age on a strip of land that no longer exists. Children walking across a lakeshore 23,000 years ago, leaving footprints they never imagined would outlast every civilization that came after them. People in simple boats, following kelp forests down a coastline the ocean would later erase. Every time we think we found the beginning of this story, the ground gives us an older one, which means the true first chapter of the human story in the Americas might still be out there, waiting under the sea, or under a lake bed nobody has dug up yet. The next set of footprints might already be intact somewhere, quietly waiting to move the timeline back again.